And welcome back. This is episode number 7 of this tutorial series / crash course on ROS Noetic. You can find the series playlist in the description. And let's get started. So now that you have a basic understanding of ROS topics, let's actually write a topic publisher in a Python node. Okay, so publisher first, and then we're gonna focus on subscriber. So we're gonna create a new node here. I'm gonna go in my Catkin workspace, source, my robot controller package, and script folder. We already have my first node, and I am gonna create a new file. And what are we gonna do here? We're gonna control the turtle. So we're gonna start the turtle sim node again, and we're gonna make it draw a cycle. And so as you will see, drawing a cycle is actually maybe easier than drawing a square. We will not even need to do a closed loop control. Just sending data on the command velocity topic. And so let's name it draw cycle.py. So we have the file here, and let's make it executable. Okay. And now let's go to edit this. I'm just gonna go in my source folder of the Catkin workspace again, code dot, and I open Visual Studio Code. So we have our first node here, but I'm gonna go in draw cycle, and let's start with first the interpreter line. So user bin and Python 3. We're gonna import ROS1 again, and then let's do if name is equal to main, and the first thing we're gonna do before we even think of creating a publisher is to initialize the node ROS1.init node, and we need to give a name. Let's name it draw cycle. So here I'm gonna use the same name for the node and for the executable name. I just used a different name for the first node just to show you that this is actually something different, but you can use the same name if you want. All right, and let's also say ROS1.loginfo node has been started. Now I am going to create a publisher. So if I want to send some data, some messages on the topic, I need to create a publisher object. So let's put pub is equal to ROS1 dot, then you have a publisher here class. So publisher, that's very easy. Okay, ROS1 dot publisher to create a publisher. You need to give first the name of the topic you want to publish to. This is super important. You have to give the exact name. So how to get the exact name? Well, let's go back here. I'm gonna start, so ROS master. I'm gonna start here ROS run the turtle sim node. So turtle sim node. Okay, we have the turtle, and now I'm gonna do ROS topic list. And what we want is that one. Okay, turtle1 command velocity. That's the one that's gonna allow us to send some velocity command to this node here, which controls the turtle on the screen. So I'm just gonna use that directly here, /turtle1 /command, so cmd underscore vel. This is super important to use the exact same name. And after the name, we need to, you see that data class. So this is actually the type of the message you need to send. Okay, because for a topic, you have a name and you have a data type. The data type for the topic is, so if I do ROS topic info, and then I use that one, I will see that I need to send a geometry message /twist. And what's inside, so ROS msg show with this. What's inside, as you can see, this is a bit more complex, but here we have kind of two messages inside the message. We have first a vector 3 linear with x, y, z, and vector 3 angular with x, y, and z. So now we know what kind of message we need to send and how is it organized inside the message. So what kind of data we can fill, okay, to send on the topic. So let's use actually the twist here. So geometry messages twist. So let's use that in our code. And to import that, well, we will need to actually import the message. And so we're gonna do from geometry. As you can see, it's already installed, so I have the auto-completion. So geometry msgs, okay, just as we have here. And then it's not gonna be slash, it's gonna be dot msg, because we're gonna go in the msg folder of this package to get the message. Import twist. Okay, we import the twist message from the message folder of the geometry messages package. And now we have twist, we can put twist here. Okay, we use twist here. Now that is very important. We use geometry messages package. So this is actually a new package that we didn't know before, we didn't use before, and because we use it now in this package, in the my robot controller package, we need to add a dependency in the package.xml. So what I'm gonna do is I'm simply gonna copy build depend here, and then I'm gonna put here geometry msgs, and I'm gonna also do this. So let's keep things simple here, okay, just geometry messages, and this exec depend also geometry messages. Okay, I'm gonna save package.xml, and so now we have ROS1, turtle sim, and geometry messages. Let's close this and let's go back to the code. So we have our publisher object with the name, the type, and there is a third argument I'm gonna put is queue size. Okay, I'm just gonna put 10. So very basically, queue size is gonna be kind of a buffer, so that if you send messages, so let's say you are in a wireless network between different computers and robots, and the network is not that reliable, and you're sending a lot of messages. And so with a certain buffer, it's gonna help the subscribers to be able to get the messages. Okay, here the buffer is gonna hold 10 messages. So here we don't have any problem in most applications, especially if you learn or if you just run everything on the same computer or on the same robot. This is not gonna matter for now, so you can just use queue size 10 and you won't have any problem as for now. Great, so we have our publisher object, and now what we want to do is, let's say we want to publish a new command velocity 2 times per second, so at 2 Hz or every 0.5 second. In this case, I'm gonna simply use the structure we have used before for the first node, which is to create a rate and then do this infinite while loop structure. So let's do rate is equal ROS1.rate at, let's say, 2 Hz, and then while not ROS1.is shut down. So as long as the node is alive, we are gonna do something. So let's put here send, so actually publish command velocity, and we are gonna do rate dot sleep, so that this is gonna kind of regulate the loop so that it's gonna do this action at 2 Hz exactly, or almost exactly. And now how to publish something on the topic, how to publish something on that topic. Well, if we go back to the terminal, as you can see, we need to send a message. So we first need to create a message and then send it to the topic. Just like if you want to send a letter to some address, well, you have the address, which is the topic name. You first need to create the letter, okay, you need to write the letter, and then you need to send it to the address. But first you need the letter. So you need the message. We're gonna create a message. Let's name it msg is equal to, and how to create the message, just twist. So this is actually a class, so you just create an object from the class twist, okay, of the message. And now you can do msg dot, and with the auto-completion we have here, you can see the different fields. So you have angular, linear, so I can do, for example, linear dot x, and I can modify the x field in the linear of the message, just like we could see here in the terminal. So we have twist, inside we have linear x, y, z, and angular x, y, and z. And now, well, if you want the turtle to make a cycle, this is actually very easy. You just need to give two commands to the turtle. You just need to say to the turtle, go straight, and also turn to the left or turn to the right. And if you keep the same command all the time, it's just gonna make a circle. Okay, so just trust me on that. You're gonna see it's very easy. So I give a linear x command. Why is that? Because, so this is the turtle. How are the coordinates working? So you have the coordinates here, starting at 0, 0, x here, and y here. You also have the coordinates of the turtle, and the x is basically going this way. So always going in front of the turtle. So if you give a x linear velocity, you just tell the turtle to move. So if it's positive, let's put 2.0. If it's positive, it's gonna move forward. If it's negative, it's gonna go backward. And then I do msg dot angular dot z, because, well, this is quite simple. Here we are not in 3D, we are just in 2D. So the angular x and the angular y actually don't exist in this plane. So here we just tell the turtle to go straight, and we also tell the turtle to rotate. So it's gonna do this. It's gonna do a cycle. So let's put just 1, for example. Okay, and the message is complete. We don't need to actually fill all the fields here. We don't need to fill everything, okay? If you don't fill everything, the other fields, like this one, the y, is gonna be default value, and the default value here, I think, would be 0. Okay, so this is how you create a message. You create the object, and then you fill the different fields of the message with the different values that you want. And I'm not gonna go very far on this cycle mathematics, because that's really not the subject here. Here the goal is to learn how to use topics. So let's keep things simple. And now, well, we have our message. That's just a message. If you write a letter but you don't send the letter is not gonna arrive. So what we do is we do pub dot, so publisher, and in the publisher we have a publish method. And what do we publish? We publish the message. Okay, so that's very simple. Publisher dot publish what? The message. And then we do write dot sleep, so that we can keep this loop at 2 Hz. So to recap here, we first import everything we need, so ROS-by, and then the geometry message, twist message. In the main, we initialize the node, we print something, we create a publisher object with the name of the topic, the type, so the data type for the topic, and a queue size, and then we create a structure to run at 2 Hz, and in this structure we create a message, we fill the different fields of the message, and we publish the message on this topic. So now we can say that this node is going to be a publisher on the command velocity topic. Let's save this and let's go back to the terminal. So I still have this ROS master running here, the turtle sim node here, and what I'm going to do is, so let's clear that, ROS run my robot controller draw cycle. So let's press enter and let's see what it does. And the turtle is making a cycle, and it's continuously making a cycle, so the same cycle. Okay, so if you want to make a bigger or smaller cycle, you can just modify the 2 values here. You can experiment by yourself. All right, great. Now, if I do ROS topic list, you can see that, well, now we still have the common velocity. We haven't created a new topic. And if I do ROS topic info with the common velocity topic, now you can see that we have we have the subscriber, which is the turtle sim node, and we have a publisher, which is the draw cycle node that we have just created. Okay, if I do RQT graph, great. So let's refresh, everything is good. We have the turtle sim node, and now we have another node, the draw cycle node that we just created here, which is now publishing on the turtle1 common velocity topic. And well, because it's publishing and because that node is subscribing, then it's just like we are sending data to the turtle sim node and we are moving the turtle. And so I'm just gonna finish here by saying once more that this is super important here to use the same name and the same message. Okay, if you don't use the same name, you're just gonna publish on a different topic. And if you use a different message type, you're gonna publish on the right topic, but you're gonna publish the wrong data. So any subscriber will not be able to read what you are sending, okay? So you need to use the same name and the same message on both sides of the topic. And congratulations, you have written your first ROS publisher. Alright, that's the end of this episode. If you found it useful, you will definitely like my full course named ROS for Beginners. This course contains 6 hours of content and will teach you everything you need to create complete ROS applications. You can find the link in the description. Thank you for watching, see you in the course or in the next tutorial of the series.